Go to it.
Good morning to you all. Let us discuss the ORIFICE meter. ORIFICE meter. This is the ORIFICE meter. ORIFICE meter is a flow measuring instrument. This will, what is the working principle or technical concept behind this, which ORIFICE meter means Bernoulli'S equation. Okay, Bernoulli'S equation. For Bernoulli'S equation, there are three practical applications. One is venturi meter, second one is ORIFICE meter, third one is p-torture tube. So when we compare venturi meter, ORIFICE meter is the cheapest device, and venturi meter is a costly device, and it is having higher coefficient of discharge value. For this ORIFICE meter, coefficient of discharge is around 65%. Okay, coefficient of discharge for venturi meter is 85%. Why this much reduction is taking place in this ORIFICE meter? So there is a sudden contraction taking place. Because of this sudden contraction, and after this smallest area, sudden enlargement, sudden expansion is there. So because of this sudden contraction and sudden expansion, the outlet discharge at outlet is taking reduction is taking place. So coefficient of discharge means actual discharge by theoretical discharge. So actual discharge is getting 65% of actual theoretical discharge. So when we compare with the venturi meter is having a tapered section in the diverging portion. So losses are less, and also converging portion is also so short. Understand? So there may be a certain contraction also, but not this much. That is why losses in the ORIFICE meter is loss in actual discharge in ORIFICE meter is more. That is why we are getting 65.65% of the theoretical discharge. So now we are going. What is basic principle in determination of discharge is Bernoulli'S equation. So to calculate actual discharge, we need manometer. So there is one section, this manometer, how to YouTube manometer is there. So here we are assuming section 2. Section 1 and section 2. Okay. Here this is the pipe diameter. This is the ORIFICE diameter. Orifice is nothing but a small hole, and here diameter is very less. Understand? Here is the equal to the pipe diameter. Understand? So what is the diameter? Diameter of orifice is dia of orifice is about 0.5 times to the diameter of the pipe. 0.5 times to the diameter of the pipe. So it maybe varies between 0.4 to 0.8. 0.4 to 0.8 of the diameter of the orifice. Okay, generally we will keep 0.5. That is half of the diameter of the pipe. So orifice diameter is equal to the half of the orifice pipe diameter. Okay. Now we are going to find out the derivation of expression for discharge through orifice meter. Expression for discharge through orifice meter. So for that we are considering one orifice meter and we are taking one U2 manometer and we are connecting U2 manometer at the left side and the right side. See, being here is a diameter less, so velocity will be more. So velocity is increasing means pressure will decreases. Therefore, the manometric fluid flows into the left side. Okay, this is the difference in manometric level. This is U2 manometer. Okay. Before solving this derivation, we are assuming certain conditions. Let P1 pressure of fluid at a section section 1. Next to V1 velocity of fluid at section 1. Section 1 and Z1 datum or elevation at section 1. D1 dia of pipe at section 1. A1 area of pipe at section 1, that is equal to pi by 4 d square. Similarly P2, V2, Z2, D2 and A2 are the corresponding parameters for section 2. Okay, pressure at section 2, velocity of fluid at section 2, diagram head at section 2, diameter of the pipe at section 2, area of the pipe at section 3, and also let D naught is the diameter of area of orifice. So to have further steps, let us erase this diagram. The basic principle used in this derivation is Bernoulli's equation. Okay, by applying Bernoulli's equation for section 1 and section 2. Section 1 and section 2. P1 by rho z plus V1 square by 2z plus Z1 is equal to P2 by rho z plus V2 square by 2z plus Z2. Assume P1 by rho z plus V1 square by 2z, P2 by rho z plus V2 square by rho z. Since Z1 is equal to Z2, so we cross out. And bring P1, P2 minus P2 by rho z to the left side of the equation and take V1 square by 2z to the right side of the equation. P1 by rho z minus P2 by rho z is equal to V2 square by 2z minus V1 square by 2z. Implies P1 by rho z minus P2 by rho z. Take the LCM. Rho z is equal to V1 square by minus V2 square by 2z. But P1 minus P2 by rho z is equal to H. It's a pressure head. Therefore, H is equal to V1 square minus V2 square by 2z. Okay. So take the cross multiplication. So what will happen? 2z H is equal to V1 square minus V2 square. V1 square minus V2 square. Now write this expression for V2 square is equal to V1 square plus 2zH. V1 square plus 2z. Assume this as equation 1. And also V2 is equal to square root of V1 square plus 2zH. Assume it as equation 2. Why we considering this Werner conductor means to solve the theoretical discharge expression we need coefficient of contraction. That is why we are including Werner conductor also. Coefficient of contraction. Coefficient of contraction. See, this is equal to ratio of area at section 2 divided by area at Werner conductor. So this is equal to section 2 to area A2 and area at Werner conductor A0. Okay, this is represented with the CC, coefficient of contraction. So what we can write, A2 is equal to A0 into CC. A2 is equal to A0 into CC. Next, consider from continuity equation. Q is equal to A1 V1, that is equal to A2 V. Here we are considering two sections, and that is why we are using A1 V1 is equal to A2 V. Now consider A1 V1 is equal to A2 V2. Now V1 is equal to A2 by A2 V2 by A1. Okay. Put A2 is equal to A0 into CC. Implies V1 is equal to A0 into CC into V2 divided by A1. Okay, let us consider equation 1. This is the equation 1 by equation 1. V2 square is equal to V1 square plus 2ZH. Okay. 1, 2, 3. This V1 expression we can assume as equation 3. So put equation 3 in the equation 1. So V2 square is equal to A0 CC into V2 by A1 square plus 2ZH. Same equation. Okay. Now V2 square minus, otherwise write one more step. A0 square CC square V2 square by A1 square plus 2ZH. V2 square minus A0 square CC square into V2 square by A1 square is equal to 2ZH. Okay. Here V2 square is there. Here also V2 square is there. So make it common. V2 square 1 minus A0 square by A1 square into CC square is equal to 2ZH. Is equal to 2ZH. Is equal to 2ZH. Okay. Now, by cross multiplication, write it V2 square is equal to the H divided by 1 minus A naught square by A1 square into CC square. This is the V2 square. So write V2 is equal to square root of 2H divided by 1 minus A naught square by A1 square into CC square. This one. Stop writing. Square root of 2H divided by square root of 1 minus A naught square by A1 square into CC square. What is this? Q2. Okay, Q2. So from continuity equation, Q is equal to A2 V2. We can consider. Okay. A2 is nothing but A naught into CC into V2. Since A2 is equal to A naught into CC. Say, assume it as equation 4. This equation A2 is equal to square root of 2x by 1 minus A naught square by A1 square to CC square. Put above equation 4 in the put equation 4 in the above equation. Q is equal to so A naught CC into what is this V2? What is the expression? 2ZH by square root of 1 minus A naught square by A1 square into CC square. Okay. Simplifying A naught CC 2Z divided by, here is a fraction, so we can take it as LCM. We can consider LCM for that ratio 1 minus A1 square minus A naught square by A1 square CC square. Okay. So take this square root of A1 square. So it will come to the numerator. So Q is equal to A1 A naught CC into square root of 2CH divided by A1 square minus A naught square into CC square. Okay, this is the expression for discharge through the ORIFICE sphincter. So if we have pipe diameter, ORIFICE diameter, coefficient of contraction, pressure difference H, then we can calculate ORIFICE discharge through the ORIFICE sphincter. Therefore, the discharge through ORIFICE sphincter can be calculated by can treat it as a 5, equation 5. Above equation 5. Okay. And one more information. Coefficient, the relationship between coefficient of discharge CD and coefficient of contraction CC and coefficient of velocity. Coefficient of velocity CV is given by CV is equal to CC into CV. CD is equal to CC into CV. Now write the expression for CC. Implies CC is equal to CD by CD. CD by CD. But CV can also be written as CV is equal to square root of 1 minus A naught square by A1 square by square root of 1 minus A naught square by A1 square into CC square. Into CC square. Okay. Therefore, CC is equal to CD into CD divided by 1 minus A naught square by A1 square divided by square root of 1 minus A naught square by A1 square into CC square. This is equal to CD into 1 minus A naught square by A1 square into CC square divided by 1 minus A naught square by A1 square. CD CC is equal to. Okay. From equation 5, 2 is equal to A naught A1 CC into 2ZH divided by A1 square minus A naught square. Okay. This can also be written as CD into square root of 1 minus A naught square, or one more thing is put CC is equal to CD into 1 minus divided by 1 minus A naught square by A1 square. Q is equal to A naught into A1 into two Z H divided by square root of A1 square minus A naught square into CC square into CC. Okay, the next step will substitute this value. Q follows. Q is equal to A naught A1 into square root of ZH divided by A1 square minus A naught square into CC square into what's the value of CC? CD, this one, into 1 minus A naught square by A1 square CC square divided by 1 minus A naught square by A1 square. A naught into A1 into square root of ZH divided by A1 square minus A naught square into CC square into CD. Take the LCM for this. 1 minus, A1 square minus A naught square by A1 square into CC square divided by A1 square minus A naught square by A1 square. Square root of A1 square, square root of A1 square will be gets cancels. Okay, these square root of A1 square minus A naught square into CC square will be gets cancels with this term. Square root of A1 square minus A naught square into CC square. So what are the remainders? A naught, A1, CD, square root of 2CH divided by square root of A1 square minus A naught square. If you observe the discharge equation, previous equation, in terms of coefficient of contraction, the expression is different. A naught into A1 into square root of 2CH into CC divided by 1 minus A1 square minus A naught square into CC square. But here there is a no terms of CC, only coefficient of discharge terms. Okay, in any problem, if coefficient of discharge given, use this problem. In any problem, coefficient of contraction given, use equation 4. Understand? Okay, so by giving the various values, we can find out the required values. The discharge through ORIFICE meter is given by Q is equal to CD into A0 into A1 into square root of 4CH divided by A1 square minus A0 square. A1 square minus A0 square. This is the theoretical expression. We can use these expressions. We can use these expressions in problem solving and also in fluid mechanics laboratory. H is the pressure difference, pressure head. How to calculate it? How to calculate it? Case 1. Case 1. If manometer is having heavier fluid, SH, specific gravity of heavier fluid SH, then and pipe is having lighter fluid. SL, specific gravity of lighter liquid. SL. Then H is given by H is equal to delta X into SH minus by SL minus 1, where delta X is the difference in liquid level in manometer. Sometimes manometer may have lighter liquid and pipe may have heavier liquid. In that case 2, if manometer is having lighter liquid or specific gravity SL and pipe is having heavier liquid, then H is given by delta X into 1 minus SL by S naught. Where S naught is the specific gravity of the pipe liquid. And also, in this equation also we can change the terminology. Yes, sir. In this way, we can find out the pressure head by using manometer. If you have any confusion, if we can remove this, have specific gravity, yes, not. Pipe fluid is having specific gravity, yes, not. Here also, pipe is having pipe fluid is having specific gravity, S naught. Then we can use this. SH is a heavier fluid. Specific gravity, S naught is the pipe fluid specific gravity, SL is the specific gravity of the light liquid. Delta X is the same as difference in the liquid level in the manometer. So by using this, we can calculate pressure head and from pressure head to theoretical discharge. All these expressions will be measured in the laboratory and we can calculate the actual discharge, theoretical discharge, coefficient of discharge, and sometimes the coefficient of contraction also. In numerical problem, by using the given data, we can, with help of given data, by using appropriate equations, we can find out the required data. So by this class, I am concluding and closing the entire session regarding the ORIFICE meter. Thank you.